I'm Scott Ashford. I'm the Carney Dean of Engineering at Oregon State University. And I've been a member of ERI for my entire professional career.
My name is Gilberto Mosqueda, and I'm a professor of structural engineering at the University of California, San Diego. I've been here at UC San Diego for about 7 years. Prior to this, was a professor at the University of Buffalo for about another 8 years.
I'm Ben Mason. I'm an associate professor in the School of Civil and Construction Engineering at Oregon State University.
I'm Jeff Berman. I'm a professor at the University of Washington in structural engineering. I am also the operations director for the Erie Rapid facility, reconnaissance facility that houses equipment for natural disaster reconnaissance.
Daniel Zepeda. I'm with Degan Cove Engineers. I'm a principal at Degan Cove in the Los Angeles office.
My name is Michael Olson, Associate Professor in Geomatics here in the School of Civil and Construction Engineering, Oregon State.
My name is Armin Studleim. I'm an Associate Professor of Geotechnical Engineering here at Oregon State University.
My name is Judy Matrani-Reiser. I'm the Director of the Disaster and Failure Studies Program at NIST, which stands for the National Institute of Standards and Technology.
If I had to make it very concise, it is to go to the field after an earthquake happens as soon as possible and collect the perishable data that you consider to be the most important from that event.
I guess growing up, doing my PhD studies and first years as a faculty, doing a lot of lab testing, got to see a lot of damage to structures in a controlled environment. So a reconnaissance kind of turns a city or a large region into a laboratory that allows you to learn from a significant portion of structures that are subjected to strong shaking. So I think a reconnaissance provides a significant opportunity to learn on what works and what doesn't work in practice. Where can we improve our structures? And we tend to focus on the structures that are damaged. And that's, of course, important because this is exactly what we want to prevent in the next event. We could also look at what works, what worked well, and so forth.
I would define it as immediate whenever possible. I think that there are some ethical boundaries around immediate that need to be considered, but getting out into the field as quickly as possible so that we can kind of take a snapshot and quickly collect as much information as possible to understand the impact that earthquake had on the community that it hit.
From my point of view, earthquake reconnaissance is defined as the observation of performance following earthquakes, to learn what worked and what didn't, to observe natural phenomena, and to improve our understanding of the hazard and the effects of our hazards.
Reconnaissance in general is a data gathering activity, but I would be hesitant to limit it to kind of the engineering side, I guess. I think there's a social component, a policy component.
In reconnaissance, an earthquake reconnaissance, the way I've experienced it, we're only there to learn, and we basically get out of the way for the first responders, if you happen to be in a reconnaissance team that goes on early on, and also get out of the way of those that are tagging buildings because they're also doing their civic duty to get people back in the building.
The whole purpose of an earthquake reconnaissance is to collect perishable data, what worked and what didn't work, before it's cleaned up, in the earthquake recovery.
Yeah, I think the key thing of why this is so important is to really document what's happened and what the extents were, so we can back calculate what were the forces that actually happened, what design methodologies worked and didn't work. And I think what's particularly important is collecting very detailed data on measurements and getting that information so you can see are these models and design procedures that we're doing, are they really matching reality of what happened?
So when I did my PhD work, I was doing a lot of modeling for the PEER Center, the Pacific Earthquake Engineering Research Center, and my PhD focused on integrating loss of functionality economic losses and loss of life into a performance metric. And in doing that and developing the models for that and integrating kind of existing models, I realized that we lacked data. We actually lacked a lot of data that could help inform a lot of the models that I was trying to develop. And I sought out data wherever I could, but I was frustrated that a lot of the data I wished I could have just didn't exist. And so then I decided that I needed to make a difference in that realm and say, if we want to have better models and we need better data to support those models, and what would be ideal. And at the time, out of the 3 areas that I was working on, I was really quite interested in how we model fatalities, and I was quite interested in how we model loss of functionality. And so in the Chile earthquake, I actually developed a tool that would look at loss of functions of critical buildings, and so hospitals specifically. And I said, if we want to model how hospitals lose functionality, which I was quite interested in at the time and still am, then we need to collect kind of systematically all this data from those facilities.
Well, in a word, because it's important. And so, especially from a geotechnical perspective, we still have a lot to learn about geotechnical earthquake engineering.
So I think the value of collecting that information is extremely important.
Getting involved in reconnaissance efforts allows you to observe phenomena that occurs during earthquakes, to learn what works and what didn't work, and take that information back home, both into the classroom and into practice, so that we can improve our preparation for our expected large Cascadia subduction zone or perhaps smaller faults.
So when I was in San Diego, I was doing research on coastal erosion. We kind of developed a rapid response program down there. When there was a collapse of a sea cliff, we had the ability to go in and collect data quickly before the waves kind of took things away. So I kind of got involved in that, mobilizing quickly and thinking about kind of what you need to do. In terms of surveying, there's things that you have to do to get the highest quality product. But in reconnaissance, you need information quickly that maybe isn't the most accurate you can get, which takes weeks to months to process. But you need an answer quickly, so you got to think of workflows that get you a pretty good accuracy system with that. And so when I started here at Oregon State, it was basically less than a month after I started when the tsunami happened in American Samoa. And at that point, the GEAR team was looking for somebody that could do terrestrial laser scanning. Rob Cahan was kind of the pioneer within GEAR to do the laser scanning work and so on and collect that data. And he was unavailable to go, and so GEAR was kind of frantically, okay, who's available? And and I got volunteered, and said, okay, can you ship out, in a couple days to American Samoa? Just starting here, trying to get adapted to everything, just moved up here and whatnot. So went down there on that reconnaissance effort, and then kind of at that point, then got involved where several people said, oh yeah, you can do all this with the scanning data, and kind of expanded from there.
I got involved in earthquake reconnaissance because I'm a geotechnical engineer by training, and it seemed to me that that was a way that I could help.
I started reconnaissance with the 2011 Japan event. I went quite a few months after as part of NSF Rapid grant. So it wasn't part of the main reconnaissance that occurred directly after the earthquake. After that, I went to Napa, California in 2014, about 2 days after that earthquake occurred, with my colleague Andre Barbosa. In 2015, I went to Nepal twice as part of a larger GEAR, which is the Geoengineering Extreme Reconnaissance Events team. And so we did 2 separate trips because it was such a large event. And then most recently, I've been to Indonesia in 2018 following the September 28th, 2018 earthquake and tsunami that they had there. And I was the leader of, again, the GEAR team, the Geoengineering Extreme Events Reconnaissance.
So my first reconnaissance was at the 1989 Loma Prieta earthquake. And I did levee inspections for the city of Watsonville. And I got to say, the first time I saw a sand boil. Um, it was an amazing experience, and it kind of put all that stuff we're learning in class. It really made it real for me. Since then, I've participated in over 15 post-earthquake reconnaissance efforts around the world.
The first one that I participated in was in 2010, was the Bio Chile earthquake, and that was with EERI's Learning from Earthquakes program. Soon after that, I participated with the EERI Learning from Earthquake program in the 2011 Canterbury earthquake in New Zealand.
I've done a few reconnaissance trips throughout the years. I went to the 2010 Chile earthquake, and then soon after that there was a small earthquake in Baja that I also was a team member. That one was a fairly short trip. I also led a reconnaissance team for Taiwan in 2016, and then also one for the Mexico City earthquake. And the one in Mexico City, I was the team leader for a group that was representing CIOS, the Structural Engineering Association of Southern California, and all the other ones, we were internal Degenkolb team.
I've only been on one earthquake reconnaissance mission, and that was way back in 2004 in Italy, the L'Aquila earthquake.
In a lot of reconnaissance, my role has been really coordinating the field data collection in terms of terrestrial laser scanning, GPS, total station measurements, and those kind of things. So I've been involved in reconnaissance missions. First one was American Samoa after the tsunami hit there, and did several terrestrial scans at some of the sites that were impacted. That was through gear, and there were actually just two of us. It was a smaller kind of reconnaissance team, and we teamed up with a bunch of coastal people working on projects with that. And then after that was Chile. So that was through an NSF rapid proposal that Solomon Yim was the principal investigator with, and we worked with some folks at the University of Hawaii and went down to several sites and not only documented earthquake damage but also tsunami damage at several different sites throughout there. And so my role was kind of to lead the survey efforts again to collect terrestrial laser scan data across these different sites. After that, the next one that we were involved in with was Japan. I wasn't able to physically go, but coordinated several grad students that were involved in the field data collection, and kind of helped orchestrate that. That was funded again through an NSF rapid proposal to collect data on different structures affected by the tsunamis. And so we had two of our grad students that went, worked with different people from the Building Research Institute in Japan, and so kind of coordinated with them so that they knew what they needed to kind of do in the field, got them trained up in, they had surveying backgrounds, but it's a whole other experience to survey in those types of environments. And then been involved in several in New Zealand after Christchurch. It was actually a couple years after we surveyed a bunch of homes affected by rockfalls and collected the field data. And so that was, again, a rapid proposal. I collaborated with Joe Wortman at the University of Washington. And so kind of helped coordinate that field effort as well as assist with the data collection and those kind of things. And then Kaikoura, we were part of the gear team, and again, kind of led the terrestrial laser scan acquisition part of that. I'm probably different than your typical reconnaissance person. A lot of times it's, say, a structural engineer or a geotechnical engineer that's kind of more interested in a phenomena. And I'm more interested in the data collection and how that's being used, and really promoting better practices in terms of collecting the data and making sure that that data is usable to people down the road.
As a geotechnical engineer, what things that I'm looking for, so you're looking for evidence of liquefaction, and I think one of the interesting things, or what you want to do is not just, well, there's liquefaction here, but to look at where isn't there liquefaction, and that helps us get some bounds on the size of earthquake or the distance from a fault for a given size earthquake where we might observe liquefaction. Um, Also, we're looking at lateral spreading, and if we can get accurate measurements of lateral spreading, that's going to help trim that. I mean, that's how a lot of the models have been developed. Um, Personally, I'm always looking at foundation performance. If we have lateral movement, bridge abutments, if there's any pile failures, that sort of thing. Looking for those, and again, getting the measurements and getting the details in the field. And then also slope stability. And there you're looking at the size and shape of the failure mass. Later on you can get the information about the soil properties, but getting that failure mass shape in the field before it starts getting bulldozed away is really important.
Most interested when I'm in the field of looking at structures that we don't necessarily expect to be damaged.
For me, that means bridge foundations and the soil structure interaction that occurs during seismic events, the development of liquefaction, or the performance of ground that's been improved to mitigate the effects of liquefaction. But when you go through a reconnaissance effort, you really do need to be a jack of all trades and just absorb everything you can and make as many observations as you can, because you've got limited time and you do need to triage the situation.
You actually want to give it a little bit of time. When you're looking at responding to the earthquake, you really want the rescue efforts to be done so that you're not in the way. A lot of times that's like a week, maybe 2 weeks, depending on the size of the earthquake and where it is. Harry Seed, the geotechnical professor at Berkeley, he always said wait till the hotels open back up. It's one, you just don't want to get in the way. You also don't want to be taking resources away from the people that are trying to begin to rebuild their lives.
When we went to Taiwan, about a week after the event. I think we were the first team that went there. We were coordinating with ERI and making sure that ERI knew that we were there and what we were seeing and our recommendations. We were there a week after, and they had already cleaned most of the large structures. They had already demolished them, taken all the rubble away from the streets, rerouted main water lines, and so on and so forth. So it's a case-by-case basis. You want to get there as soon as possible so you can observe the most amount of damage and learn the most.
I don't think that there ought to be a set time frame. I think that it's really important to document damage as soon as it happens and before it gets cleaned up. But at the same time, we don't want those activities to learn from the event to prevent important emergency response activities from happening.
That ideal window is really you need to be, and it changes with the scale and scope of each natural disaster. You need to be outside the first responders. We need to not be in the way of the first responders. That, life safety is critical. We need to get people safe first. Then go in and collect the data before the bulldozers come out. And so that changes with each natural disaster. Social science reconnaissance activities can happen over years.
Well, since you've asked me how soon in an ideal setting, it really should be 24 hours. That's the ideal departure time because much of the effects of earthquakes on soil deposits are perishable. That is, the ability to make those observations following an earthquake reduces substantially with time. And so we'd like to mobilize very quickly.
I think maybe the ideal time is, once the recovery efforts die down, it's probably 3 to 7 days after an event, depending on the magnitude of the event.
It depends on the scale of the event, and it depends on the type of data to being collected. But one of the most important things to consider is what that life safety situation looks like. And so in all these reconnaissance efforts, what you've got to do is just really look at, where are the people in the area at? And, if they're not, in a position where they're getting supplies and food and other things in there, and you're coming in to do all this work, you're potentially taking away resources from them, right? By renting a car or, you know, getting the food and so on. So there's a lot of thought that gets put into, okay, is it safe for these teams to go down there? And, are they in a position where they're going to be helping the local economy versus, taking resources away?
Well, ideally you deploy as soon as possible because data is very perishable. First thing you do is you build those in-country partnerships. You find the organizations in country that mirror things like EERI, like your VERT program, for instance, and you start building those contacts. Careful before you go to the field is social media, and this helps direct us. And in the case of Indonesia, because people were taking videos with their phones, we are directed very specifically to locations that we knew were going to be of great interest to collecting the types of data that we could bring back and then develop our models further.
As a reconnaissance team member, we really want to begin observing any local news reports that are coming out of the area to see what kind of photographs have been taken to document particular damage. We want to understand the response or observations of general people, after their experience with the earthquake, and certainly we want to review the USGS shake maps and any kind of information coming out of the USGS so that we can understand the likely magnitude of the event, the scope of reach as far as how many people felt it, and what kind of intensity that was observed for folks that reported to the Did You Feel It app or website from the USGS. So we really want to see what kind of immediate information comes out so that we can best judge what a team should look like, how large, and how quickly to mobilize.
Thinking about what equipment you need, how are you going to document the damage, how are you going to measure the damage. So I think those things are really important. Understanding the culture and community of where you're going, that is extremely important.
At NIST, we actually have developed a rubric to evaluate every event that we're considering to deploy to. And in that rubric is included, exposure, number of fatalities and injured, the intensity of the event, the severity of structural and non-structural damage to engineered and non-engineered buildings, damage to infrastructure, as well as any challenges in emergency communications and response procedures. So all of these things are kind of taken into account in this quantitative rubric. And in addition to that, we also have a qualitative part to the rubric where we're asking questions. Is it safe for your team to go? Do you have the resources to go and support your team while they're in the field? If you go, are you going to learn something that's worthwhile?
Yeah, so there's a lot of different types of information you want to look at. So, being in geomatics, obviously everything map based, and so there's certain places that will make imagery available. So that's one of the things, is getting that kind of satellite imagery to look at the extents and nature of the hazard. Another part is connecting with local colleagues in the area. That's, I think, one of the most critical things in a successful reconnaissance, is you're really going there and working with the local scientists, engineers in that area, rather than just coming in and saying, hey, we want to learn from you, but we're not contributing.
So logistics is one thing that you have to figure out. The other thing that you need to prepare is I truly believe that you need to try to make contacts anywhere you can with folks that are local folks in the area, and I'm talking local technical folks.
VERT can collect newspaper articles that have been published immediately following the event, perhaps collect satellite imagery or any kind of LiDAR or any imagery in general that is beginning to come out of a region impacted by earthquake, and just summarize perhaps through links or repositories access to information that a reconnaissance team can use to quickly focus on those particular zones and areas of interest.
Yeah, so I think the biggest things are identifying where to go.
If there's a way for people, the members of VERT, to collect information of damage, of different, and put together maybe it's a map of where localized damage has taken place, collecting different information on maybe the soil conditions, or maybe getting some building plans for certain bridges or some buildings. Those are all things that can be of great benefit in the aftermath.
So I think what VERT can kind of play a role in is aiding in some of the image interpretation and really getting people to focus on where to look.
Any information on the hazard, the exposure, the impact that can be refined with work ahead of time that could help inform our scoring would be very valuable. And we even believe in an evolutionary scoring process where we score the events initially, and then as new information comes in, we update that score. And that score may go up and down based on the information that we're gathering or that folks are gathering on our behalf.
I think something that I would want to share with anybody doing a reconnaissance is to really be aware and have empathy for the people that have just been through that earthquake. Their lives, many times their lives have been ruined, right? And often they've lost family members and friends. And you just really want to be aware of that. You want to act in a professional manner. And you want to make sure that you're not seen as an earthquake tourist. That, and it happens. I've seen people in the field. I've seen residents affected by earthquakes kind of complain about, the earthquake tourists, and it's very difficult because seeing the effects of an earthquake firsthand, it's amazing, and it's incredibly exciting to see what you've only read about. But you got to keep that excitement on the inside, because your excitement is really in the face of people that have maybe lost everything.
It's a real opportunity to grow, not only help your science career, but help others and just grow as a person in general.
In my opinion, I think when young engineers are in school and still learning about all the various contributions to loads and resistances for both static and seismic behavior, the best thing that a student can do is take advantage of all the opportunities available to them at their school, attend seminars, meet with visitors who will come and share their observations regarding reconnaissance. And then as you graduate and take a job, particularly for those residing in seismic areas, pick one or two modes of seismic deformation or mechanisms of seismic failure that interest you, and try to do your homework through reading journal articles that might focus in on these particular mechanisms and begin to develop an expertise. And at that point, that allows you to build a network and understand how to reach out to other experts and improve your understanding of that particular mechanism, and to add value to your clients, as well as continue to grow as an engineer and better serve society as a result.
Absolutely.
I think probably the key is just really, kind of going in with the training and understanding what it's really about and kind of the objectives and goals. I think a lot of people, especially early in their career, get excited to go out and do reconnaissance because it's a way to see a lot of things happen that you don't get a lot of experience. And it's a good experience to train people, but it also, there's, you know, a lot of challenges, and there's a lot of psychological, you know, wear on you and so on that you kind of have to be prepared for.
But if you have an opportunity to go out there, certainly take advantage of the situation. I mean, I won't say a great learning experience because we're going at you know, to this tragic location. But it is from the engineering side of things, it is a significant opportunity to learn and to see, for example, things you might be hearing in class. So, you know, hearing about different failure modes, for example, and you get to see a lot of that there. And it also kind of brings actual awareness to what we're doing as a profession, you know, to trying to prevent this type of damage. So I would highly encourage anyone to try to get involved in these reconnaissance efforts.
I think reconnaissance changed my career, and I think what it does is that, you know, we're very comfortable sitting behind computers and modeling a lot of things, but once you actually see, you know, a collapsed building, even a partially collapsed building, it just makes you want to do better, you know, be a better engineer. And so I think to all the young students that are contributing to this, you know, VERT program and things like it, I would say it's very valuable. You are contributing, you know, these moments, while very unfortunate for all of those impacted, also offer an opportunity to learn from them. And so I'm a very strong believer, very happy that our professional society has created this program so many decades ago and continues to invest in it.